And you can expose it to the API. And lastly, you can extend it to new sources or new classes of sources. So a new source would be something like a new database that's being added. A new class of source would be a category of new data assets like dashboards or ML notebooks. And the goal was for this to become the source of truth for where, what, and how data is being used in the organization, and use it to power various applications. The first one being the productivity application, which will help you find this data and establish trust in those data sets really quickly. So here's another variant of this. And so there are 3 ways you want to be able to traverse this graph, so to speak. And the first one is you'll be able to search it. Next one is lineage, which is upstream, downstream, and vice versa. And then the last one is network-based, which is I can follow a user. So I can say like, hey, I just joined Stacy's team, and I want to be able to see what data sets does Stacy use day to day, so I can use it for my work as well. And lastly, because you can't anticipate all use cases, you want to be able to access these programmatically. And the kind of metadata you want to capture goes in 3 categories, which we call the ABCs of metadata. This terminology is borrowed from a paper from Berkeley called Ground. A stands for application context, which is where is the data? What are the semantics of the data? So this is simply the rows and columns in the data set. B is behavior. Who is using that data? And that could be human or application. And who created the data? Again, that could be a human or an application. The last one is change, which is how is this data evolving over time? And how is the code that's generating this data evolving over time? And what I found in my evaluation was that the industry was doing a pretty good job of A, which is just a catalog of your data in the databases, in other words, called technical metadata, but not very good job at all of B, and it wasn't touching C at all, right? And you can capture this metadata on a bunch of different data sources. So you can find that you can capture that on data stores all the way from S3 to some databases. You can grab people and put them in the graph. So you can see like this person owns this data, or this person created or viewed this data set. And you can go dashboards, notebooks, events, and schemas, and streams. And in my evaluation, I found that there was fairly good response and support for the data stores, but not enough, actually not much at all for the follow-ons. So as I thought about capturing this metadata, it was also to capture enough depth and breadth of the metadata so for it to make meaningful applications. And because the solution space is really broad, having a core application around data discovery really helped fine-tune the P0 criteria for what we wanted to build. So here's some examples of like vendors and open source projects that I picked. I'll share the slides later so you can go through them. In interest of time, I would say that different projects were focused on different things, and there wasn't any one thing that we could use, whether vendor or open source, that would solve that data discovery problem for us. There was a category of tools that relied on manual work, which is like me going to Chester and be like, hey, Chester, every month you're going to go update this data set and make sure this is the source of truth for ETA data set. And that wasn't going to work out at Lyft. And then there was a category of work that was either custom to the organization and not applicable outside, or integrate with historical databases and not the new age tooling with Hive and Presto and Airflow and so on and so forth. So ended up deciding to create this project called Amundsen. It's a Norwegian explorer who was the first person to reach the South Pole, hence the first person to reach both the poles. I am told that the name is said Amundsen, but I think it's a very hard name to pronounce for me, and I'm sure for many others. And but that's the name we chose because it was a data discovery project. So I'll share a little more about what the product looks and feels like. We'll talk about the architecture, and then we'll talk about the future. So the first page of Amundsen, you come in and you're presented with a search box, so you can type in ETA and be able to see some data. And that's the most common use case. But if you don't know what you're searching for, you can browse data. So in this example, you could, we have dummy tags, but you could search for financial data or growth data, so on and so forth. You can bookmark data sets, and we'll show you how to do that, but your bookmarks appear on the first page. And lastly, you can see popular tables. This is popular within the organization. However, in the roadmap, we want to personalize this list to you and your team. And this popularity is determined not based on activity in Amundsen, but based on activity in the databases itself. So the more queried a table is, the more quote unquote popular it is. You can search, like I said, that's the most common use case. You get a page rank style rank results. And this is ranked based on what you typed in the search box that gets matched against the name of the table, the name of the columns, the description of the table, the description of the columns, and the tags on the table. And the ordering is based on how often is a table queried, or the terminology I've been using is popular. Again, popularity is based on the query activity in the database. Once you click on a table page, you see all this information about it. So going from the left-hand side, you see a breadcrumb that says data sets in Hive. Amundsen has various different kinds of resources. You could have a dashboard, you could have a person page, and in future you could have streams and people. So the first thing tells you that it's a data set, aka a table. And the next thing tells you that it's from Hive. You may have multiple data sets, databases in the organization. So after that, you have a description. This description comes from the database, and you can update it in Amundsen, and it actually goes back to the database. Then you have issues. So what we find is that a lot of consumers didn't feel comfortable updating the description in place because they didn't know if that was correct or not. Many times they were thinking of these gotchas like, oh, this table, if you're using it, then you should always put a filter on this because there's a bunch of test rows that we need to avoid. And they didn't feel comfortable putting that in the description. So what we did was we created an issues section. So it's very easy for you to report an issue. And an issue usually would get fixed, but sometimes it's just a gotcha that may not get fixed in the short term, and that's okay for it to be listed here. And so you can file an issue, it files a JIRA, it notifies the owners of the table, and it shows up on the table page until it's resolved. And in some cases, the last 3 resolved issues still show up, and you see that they have been resolved. Next one is date range. So you get to see the start and the end for the table. Most of the metadata you will see on this table is generated automatically. You can obviously modify some bits and pieces of the metadata here, and they get persisted. But the goal here was to not have a manual, like main point of control. So for example, the date range is computed based on a heuristic of the partitioning scheme. So we see the DS or the DT column that you may have in a database, and we go to the first column, the last column for that, and figure out like this is probably the range for it.
Hey Mark, sorry to interrupt. Seems like the screen freezed. Some people say which slides?
Yeah, we only see the table one.
Okay, let me share my screen again. Thank you for interrupting. No, that's not it, I don't think. 1 second. All right. Is this better? Can you see the screen?
Not yet.
Okay. Still no?
No, he said it's started sharing, but I haven't seen it yet.
Okay. As a backup, what I can do, Chester, is I can share the link to the slides with you as well. And so worst case, I get to talk to the slides while you move them. I'm not sure what's going on.
You gonna email me?
Sure, yep.
Or you can try to share screen again to see if it's going to help.
I'm just going to do that. Chester, FYI, we're slide 18 right now. Okay. Let me share my screen one more time.
Okay, we can see the screen.
We see now.
Okay, sorry about that. Cool. So underneath the date range, you find the last updated date, which actually comes from Airflow or your orchestration system. So we know that this data set was last updated on this date. Notice that most of the time you would have a correlation between the date range and the last updated, but it doesn't have to be in case your job was failing or if the job is weekly or monthly or something like that. Then you have frequent users. This is a face pile of users, even though you can't see pictures of them. And these are top 5 users who query this data set the most. And we found that in cases where the ownership is not clear, which is the case in many organizations, you can use these people as a proxy for understanding the data set and asking them questions. And so these are, again, people who query the data set the most. You have tags. These tags can be applied programmatically. So what we had was For example, a fraud ETL job will, when it generates a new partition, will tag the data set with a fraud tag, so people know that it's a fraud related data set. But you can update and apply tags here as well. Another use case of tags is in terms of terminology. You would find that certain tables are referred by similar names, but the name of the table is different. So if you can tag it there, then the search results are influenced by it. So an example would be the rider table may also be called the passenger table. So if the name of the table has rider in it, you may want to tag it with passenger so that when people search for passenger, you get the same results. And lastly, you have ownership information. This can be, again, grabbed through an API if your organization already has a source of truth for this. And it can be modified in the product as well. So that's all on the left-hand side. On the right-hand side, you see columns. So there's your standard, the name of the column, the description of the column, and the type of the column. You also see what things are built from this data, which is the dashboards pane. So if you go to the dashboards pane, and I will not change my screen for now, but you will see a list of dashboards and reports that were built on top of this data set. That's the first kind of lineage that Amundsen has. On the top right-hand side, you would see this lineage button, which shows, which actually is a hyperlink to an external tool that Lyft has for showing dataset to dataset lineage. It's something that Amundsen is working on right now to bring it into the project so it can be used by all people. But you can also see the GitHub code and the Airflow DAG link, which was used to create this table. So that's the second kind of, so the first kind of lineage is the reports that are built on top of the data. Second kind of lineage is dataset to dataset lineage, which is both upstream and downstream data sets. And the third kind of lineage is the ETL job that was used to create this table, as well as the code that was used to generate this table. And we have all that there. You can see a preview of the data if you have access to the data set. And lastly, because it's a discovery tool, if this is the data set you want to use, we want to take you to a BI tool of sorts. So for example, in this case, the Explore button at Lyft would take you to Apache Superset, which is an internal BI tool, an open source BI tool. And so there we prepare a skeleton query for you. We say select star from this table. We choose the appropriate database. We choose the appropriate schema, and we just plant a query there for you so you can kind of get started and work on that query. A few other things, you can click on a column and you see stats for the column. You can preview, like I said before, and then if you click the dashboards, like I was saying earlier, you get to see all the dashboards that are built on it. You can go to the dashboard page and you find information about the dashboard. So here you see that the dashboard is built from actually 5 different tables and it has 4 queries in it. And on the left-hand side, you see that this was created by Tao. It was last updated at this time. Last run was successful, and it has these tags. You can also see a preview of the dashboard if you have access to it. And so Amundsen, as I was sharing before, has tables as well as dashboards. Now, you can also search for past work. So you can go and search for Amundsen-related dashboards that exist, and you can find them in Amundsen. And that's an example of a search. So search is not just limited to data sets. It can also search for dashboards and data sets, which is, and the last thing that's in the Amundsen graph is people. So you can search for your coworkers. And so in this example, I search for myself, and I can show you the data sets that I own, the data set that I bookmarked, and the data sets I frequently use. And this is one example where I was sharing earlier, as you join a team or move a new team, this searching for your coworkers is very important. So to recap, goal of the product was to get all the data automatically as possible. There are 3 key things that are in the graph today, and that's data sets, dashboards, and people, and they're all interconnected, and we were using that information to power a discovery and operational experience that wasn't possible before. Cool. So real quick into the architecture of Amundsen. Amundsen currently is 4 microservices. We'll start from the top right-hand side. There's a front-end service, which is a UI that you saw. It's backed by a search engine. The only search engine currently supported is Elasticsearch, and there's a wrapper service around it called the search service. Now we will go to the left-hand side of the graph. In the center, you will find a GraphDB, which is the centerpiece of all the metadata that's stored. We support Neo4j, AWS Neptune, and Atlas. The initial incarnation of the product only supported Neo4j. AWS Neptune was added by Square, and Atlas was added by ING. Now I would say 90% of companies use Neo4j, and about 5% use Neptune, and another 5% use Atlas as a backend. This metadata service and the search service together power the front end. This is all the stuff you saw in the demo, in the screenshots. And then the metadata service can be accessed by other services as well. So we've seen use cases at Lyft and Square and other companies that are arising where you hit this metadata directly and you're able to build other applications that programmatically either put and update the metadata or programmatically get the metadata. And lastly, the question is, how does this metadata get in the first place? And that's a lot of integration. So the integration ETL system is in Amundsen is called Data Builder. That's the fourth service. And it essentially can pull or push data from a variety of different systems. And they can be databases. They could be GitHub source files, orchestration systems, HR systems, dashboarding tools, so on and so forth. And they can be cross-cloud. So you could have your database in GCP, and you could have your HR system that's a SaaS system, and you could have your dashboarding system in a different cloud, like let's say AWS, and all that is supported. I want to share one more thing about this data builder push and pull. A pull model is when you, kind of like Google, you wake up every so often, you crawl the world and you build a view of the world and put it in the graph. And the push model is where the individual teams that own the database or the dashboarding system will send you a message every time there's an update to an existing dashboard or database, or a new dashboard or database created, so on and so forth. Amundsen was started with pull model, and the reason is because we were working in a strapped team, and pull model doesn't have too many dependencies. I own everything that I need to do, and I can do that. Push model works better when you either have near real-time use cases, which means the moment a database is created or a table is created, you need to know within a few milliseconds or seconds. And lastly, that it's helpful where you have databases and that the ownership for which should be on the other team and not on your team. So Amundsen today supports both pull and push. Push is in beta, and most people use pull just because of the history of the project, but both can work, and we find that it depends on the organization who wants to use it. Cool. I will skip this section as in the interest of time. We'll go to this one. What makes Amundsen different? You may have seen some catalogs of the past, like open source projects or some vendors. And the two things that we were looking for was, the first one is that the catalog integrates with the tools of today. So it uses Hive and Spark for ETL, Presto, BigQuery, Snowflake, etc. for data warehousing, data lake, and Mode and Looker and Tableau for dashboarding. And the second one is low time to value. So there is a lot of business and technical metadata that you can get in Amundsen through Lineage and through automation. Some of that is available today. Some of it is in the roadmap, but the idea was that we don't have to rely on a human to go put in metadata every single month and make sure it's up to date. This is a story of Amundsen at Lyft. This is the adoption of users at Lyft. Amundsen has 750 weekly actives, and this is a graph over about 2 years going up and to the right. This is a graph of who uses Amundsen at Lyft. So the blue bar shows how many people with such role are at Lyft, and the red bar shows the number of people of those roles who used Amundsen the last week. So you find that the biggest penetration rate is in the data scientists and analysts, which is 70 to 80%, and they use it every week religiously. And then you find that the software engineers have a penetration rate of about 17%. The reason is most of them work on mobile apps or server apps, and only about 20% of them, maybe data engineers working on data stuff all the time. And those are the people who use it every day, every week. Amundsen is open source, over 1,100 community members, 150 companies in the community, and 30 companies using the product in production. And so here's a few companies that use it: Reddit, ING, Square. There are a few that are not on the list, like Instacart as a recent addition, so on and so forth. And when I think about the future, the roadmap for the data discovery is to do dataset lineage, which is the one form of lineage that Amundsen doesn't have today inbuilt. Is to allow ACL integration, so only specific people can update the descriptions of the tables, so on and so forth. And then an experience around search that's improved, so you can see, kind of like Google, what was the reason why the search result was matched, and that's highlighted in the matching. And And then there's a data shopping cart experience where oftentimes what you find is people discover the data and then they have to request access to the data. And currently, without a tool like Amundsen, what you find is that people don't know what data exists, so they don't even know what to request access to. So the tool like this helps you understand what data exists, even though you don't have access to it, then go request access to it, which then gets approved. So one thing we want to do is better tightly integrate with the data access experience. So you can request data within the tool, and that integrates with whatever is in the company that grants access. Here's an example of a screenshot of what lineage in Amundsen would look like. If you're interested in this topic, go to amundsen.io, and at the bottom of the page, there is YouTube videos, and you can see a video discussing the entire lineage design. And if you have any feedback, join the Slack channel, which is also listed at the bottom of the amundsen.io page. So that was the roadmap for the data discovery application. I wanted to share two examples of things that are happening in addition, maybe a little more broader than the data discovery application. So what Square did, for example, is that they took Amundsen and they said, I'm not going to use it for data discovery necessarily. I'm going to start tagging data as email and full name and other PII information in Amundsen, and I'm going to extend the UI for people to approve or reject whether my guess was right. And so that's what they use Amundsen for. So they collect all this information, and they have extended the Amundsen graph model, which is the diagram on the right-hand side, for each column to have a few additional identifiers. So you can say PII semantic type, which is email or name. You can say that data storage type, which is whether it's encrypted or plain text, and you can say data subject type, which is this is a financial customer or a particular, it's a driver or a passenger, or so on and so forth. And so if you're interested, at the end of the slide, I'll link to a blog post that has more details on it. But the thing is, they've taken Amundsen, they use the metadata, but not for data discovery, but for access control and data classification, privacy application. Another thing that's happening in the community is that there's now integration with Feast. So not only can you discover data and dashboards and people, you can now discover features that are stored in Feast in Amundsen, and that's very useful for our data scientists. So with that, what we are beginning to see is that we started to build the data discovery and trust application, which is the application on the very left, and ended up gathering a goldmine of metadata. This metadata is now being used to develop other applications. And the example of application I shared around privacy and PII classification is in the second and third category, the security and privacy in the compliance world. And so we can find that over the long term, we would want to help these other applications solve problems through that same metadata. And that doesn't mean Amundsen will solve all these problems. It means some of them we integrate tightly with to help existing tools and products help with that too. And in some cases, we take ownership of that problem resolved there. And lastly, we are the power of product like this increases with the amount of metadata you have and the diversity of metadata. So we started with data sets. Now there are dashboards and people. You saw there's features being added in there, and there's a whole world of streams and schemas and workflows that could be added here, and that's something we want to do in the future. However, that's not short term, but it's like where we're headed. So with that, data discovery is a huge pain. Amundsen helps solve that problem. You will hear how Shopify solved that problem with Ranko in a moment. There's a huge opportunity for metadata-driven applications, and here are some codes if you wanted to see read more. So there's the homepage for Amundsen. The next one is the GitHub repository for Amundsen. The third one is a more recent blog post from me about what the problems still exist. And the fourth one is the use case that I was describing from Square around access control and privacy. That's all from me. Thank you very much.
Thank you, Mark. Great talk. So we have a few questions in the question line. The first one, I guess, is about the description of the columns. And so there's like a data dictionary. Does that have to be manually done? So is there any automatic way to do that?
Yeah, so the descriptions are not automated. They come from the database. The only thing that can be automated there, at least right now, I would love to hear if what feedback y'all have here, is using the code that generates data in order to trickle descriptions upstream or downstream. So often you may have one table that's the JSON version, and then you have a version that's the Avro version, and tools often will have you put the descriptions for tables and columns in both places, and we want you to put it in one place and then trickle that description from one thing to the other, or even connect these two things because they represent the same data, just represented in different form. So we'll do that part, but the act of writing a description is something that's usually in a human's head. So if it's not written down somewhere, you would have to add it in the first place.
Okay. The second question is, does the Amundsen crawl under unstructured data in data lake, like for example, raw text, video, and audios?
That's a good question. We haven't focused on that. For you to make use of Amundsen as it is today, you would have to have some sort of schema or understanding of that data. And so in cases like where you have S3 files, you may have an entry in the Hive metastore that represents the table name or column name, a logical name for that, and we would do that. We've had some users, maybe like less than 5 total over the few years I've worked on Amundsen, ask for something like that. We haven't built it. We are very open to new integrations in the data builder. It would require a new writing of the ETL in data builder connector. Would love to welcome that, and we can review it and commit it. But it's not a use case I've seen most common with Amundsen.
So another question is there a plan for developer jobs instead of a data set creator level lineage in Amundsen? Frankly, I'm not quite sure I understand the question. So
yeah, I'm not quite sure what the difference between that kind of lineage and regular lineage is. We're definitely planning to have lineage, but if there is anything specific, please ask again or hit me up later, and happy to chat more.
Okay. So the next question is related to what's the community plan to integrate it with the data quality tools, like, for example, grade expectations, etc.
Yeah, so one of the features today is called programmatic description, in which case you can add a description to a data set that's coming programmatically from a different source. And what you would find is that an organization, Sam Schuster from Edmunds.com, which was using Amundsen, added that capability. So what they do is they take their data quality report and they put the result of the data quality report from their data quality tool in Amundsen. So that way you see what the result of the data quality checks in the tool in Amundsen are, and then you are able to click and go to the report as well. We have that level of integration, and that works with all data quality tools, actually works with beyond data quality tools. When it comes to specific data quality integrations, we've had early stages of chats with the data quality tools to see how we can integrate them, but we haven't scoped out any real work there yet.
So our next question is, what kind of setup or infrastructure is required to take advantage of the lineage features? Like, for example, do you need an Airflow and all the other stuff?
Yeah, so specifically, so there's setup required for Amundsen, which is you had to set up these 4 microservices and they run on Kubernetes or containers, which Elastic containers. The actual stuff that's required to make lineage work is that one thing we learned is that people in the community already have some representation of lineage already stored in some place. So for example, if you're using dbt, your dbt may actually be logging lineage in a file. If you're using Databricks Delta, your Databricks Delta actually may have a table that logs lineage that's used within Databricks Delta. So where Amundsen has taken a position right now is that we will have a model in our graph for representing lineage, which means I can say this the data set was generated from this data set is used by this dashboard, so on and so forth. And we'll populate that model in the same way we populate metadata through Data Builder. So we'll go to Delta Data Lakes database and pull out the lineage and ingest into Amundsen. Same way we'll go to the database, the dbt log files, and grab them and add them into Amundsen. Then Amundsen takes this metadata and builds a UI and a graph around it and allows you to traverse it and to see what was green or red by linking it to your Airflow instance, so on and so forth. So in terms of what infrastructure What you need to provide is, if you don't already have a lineage stored in the database of your choice, then you need to generate that lineage so Amundsen can ingest from it. And in early stages, Amundsen will probably only ingest from a certain kinds of data sources, right? So we may choose like 5 databases we work with. And then if you are not one of those lucky 5, you may have to build that connector to be able to ingest that lineage. Hope that makes sense, but it's a pretty early thing for us. And if you have any feedback or thoughts on it and what databases make sense, like join our Slack channel and let's talk more.
So I want to drill down a little bit more on that question. So you mentioned that there's a Delta Lake, and table format has lineage information. There's the other 2 open source format, the Hoodie and Iceberg. So you already have a plan to, or you already have connectors to collect information on that as well?
We don't directly collect information from them. It's a topic we want to explore, but today we mostly integrate with Hive and Presto, or Snowflake and BigQuery and things of that nature.
Got it. Okay, so the other questions are coming from your previous answer. So you mentioned about the deployment model. So you're currently basically deployed through Docker containers or Kubernetes, or both?
Both.
Okay, cool. Any other questions from the community? So there's another one. So what would be the quickest recommended way for someone to try it out? Amundsen.
Yeah, you'd go to the website amundsen.io, and there's a Slack channel there in case you need help. But the GitHub link there has a getting started page, and it's very quick to actually set this up as a POC on your local machine connected to a database you have access to, and see it for yourself. And if you need any help, there's a troubleshoot channel on the Slack channel. There's over 1,100 people hanging out in Slack. Many of them are super helpful. Almost all of them are super helpful. So come join, hang out with us, and we'd love to work with you.
Okay, one more question. My question is about the tagging. So possible tags values centrally managed. How did you initially decide on which value should be the most useful for users?
Can you repeat that question again, please?
So basically, it's talking about tagging, right? So all possible tag values centrally managed. How did you initially decide on which values would be most useful to users?
Yeah, they are centrally managed. That's a good question. However, there's nothing preventing today in terms of a user creating a new tag that may already exist, or something like that already exists. The governance thing we did here was that we said all tags will be in lowercase, so you didn't get like passenger with a capital P or passenger with a small p. And so they all get mapped to a lowercase. And then we also disallowed, I can't remember exactly, but we disallowed dashes or underscores. So we wanted people to use only one and didn't want them to separate using the other one. So we did that level of things, but we found that it does require a little bit of curation in terms of like finance and payroll and driver and rider and growth. So you can actually create these tags and then maybe hit up 5 or 10 people who are owners of this area to tag a few people to kind of get that ball rolling. But if you work on bikes and scooters, and when we created and there was no bikes tag, you can go create that and there's nothing preventing you from it.
Okay. So the last question, I think maybe at time, does Amundsen support search table content, cell values, etc.? It doesn't seem like it does. Is there a reason why not? And infrastructure with Elasticsearch is there already? So I guess this is related to the search.
Yeah, I got that question. It does not. You're absolutely right. And the reason is, in order to maintain the separation of metadata and data, we wanted to search only through metadata, and we didn't want to go through searching for data. And if you want to search through data, like we get into database territory, and you may want to do a query instead of actually searching on Amundsen. So we have stayed away from it. The only case where it may make sense for Amundsen to get data right now, on the top of my head, is when you have less than a very few distinct values in terms of cardinality of a column. So if a column represents states, And your states always are 2-digit code, so you want to be able to see what states are actually in the column. You can actually, it would make sense for you to type in like Washington and be able to see the state. Or if it represents like OSs, so you can search for iOS and Android, it makes sense for you to say like, oh, I want to look for like rides using Android, and we'll show you, related columns. But that's something we haven't quite figured out. We're only searching for metadata at the moment.
Great. Thank you so much, Mark. Appreciate it. It's a great talk. So I guess the next talk is from Renko from Shopify. He's a senior product manager, and so also they implement the data discovery tool themselves. So or I don't know the details yet. So Renko to take over.
Thank you. Thanks, Mark, for that. That was awesome to see that. I'm really excited to provide our perspective. Thanks, Chester, for the introduction. So let me know if you can see the screen okay.
Yes.
Perfect. So as Chester mentioned, my name is Ranko. I'm a product manager at Shopify, more specifically product manager on our data platform engineering team, where we solve problems, data problems for both our organization and also our users. Humans generate a lot of data. I think that's a known fact. And if I may use a labored analogy of an ocean, I think like in the past 2 years, we've generated more data than the entire period in human history before that, right? So this trend of just like generating so much data is growing exponentially. And I think you may think, and most often I see analogies of people consuming all of this data is like drinking from a fire hose. But I actually disagree. I think it's more like this. I think there's something like only 0.5% of all data collected gets analyzed, right? So being able to actually organize that 0.5% in a way that people across the organization can leverage and make data decisions, data-driven decisions is super, super imperative to any organization that leverages data in their day-to-day operations. So how are some of these problems manifest themselves at Shopify? We did quite a bit of research early on. So I'm going to leverage this kind of high-level data lifecycle chart. Mark had a very similar one that he talked about. But basically, from acquisition all the way to application, we grow data assets almost exponentially. So excuse my high level and high res graphics here, but basically, when we start with the raw data acquisitions, we start with some first-party production databases. We start with some third-party extracted data sources. We apply some standard transformations, thus creating more data assets. And when I say data assets, these could be things like streams, data sets, jobs, etc. Those are then modeled, right, with a little bit more of like the business context and business understanding, and each kind of step starts to layer in that complexity and that metadata of, what are the transformations, when does it matter, when does it not matter, and then when you hit the application, that just really blows up the number of different data assets that kind of live on top of this life cycle. And again, these applications are machine learning algorithms, reports, dashboards, other more specific data sets. So what we see very quickly is that each one of these high-level stages had its own kind of way of data discovery, right? So, and it impacted different users. So let's say I'm a product manager, which I am. I come in and I ask, let's say I'm new to the company. I ask, okay, how many active users did I have at the same time last year? And I'm not able to find this. So I go to my data scientists, can you please let me know what this is? They might go and maybe find the answer in another report, or they might try and find a data set that describes this. And then they might go to their data engineer and say, hey, like, I can't really answer this question. Like, where can I find this information in the lower level tables? And then the data engineer and data scientists go off and try and figure it out. And while all that's happening, the product managers and the business folks that are answering these questions need answers. So they're not going to stand by idly. They're either going to find an answer themselves, which may or may not be correct, or they'll start another thread with another data person, right? So you can quickly see how inefficient this becomes. And again, the more people you have, this process just does not scale. So I always like to use customer quotes. And this is my favorite one that really highlighted where we were before we started this discovery journey. Lots of tribal knowledge and not a lot of communication between teams on kind of what different data assets meant and how to leverage them. And this is reflected in our research because we found that the biggest of problems existed at the intersections. Going to my very highly detailed org chart, we're organized in product teams. We have data scientists embedded within those product teams. And across product teams, that data discovery process was extremely difficult. Going to a different team and asking them what their data set often meant going through Slack channels, trying to figure out who was on that team, who produced that data, when, how. Again, all the questions, or they would just go to GitHub and try and hit GitHub blame and try and figure it out. It just was a really, really manual and super intensive process. But even within the vertical, even within the product team, if you're new within that product team, you had to figure out who the person that had the most information, who was that tribal knowledge person that you can talk to. So we saw these problems existing in sort of three main categories or three main flavors, as I like to say. We had the curation. So this is basically data scientists who are looking to figure out, okay, what are the data assets, whether it be reports or dashboards or data sets that I can leverage that exist, that I can quickly answer these questions or help my stakeholders with their problems. There were the governance issues, which highlight this idea of data management, quality, change management. So the ability to understand lineage and provenance was one of the biggest things that we found through our research. Our users wanted to understand, if I'm changing this data set or if I'm deprecating this field, who is this going to impact? That often meant sending these like large emails to all the data folks, or just like trying to reach people out on Slack. Again, it's not very efficient. Finally, accessibility. And this refers to business users just trying to figure out, can I self-serve some data points without having to engage my data scientists, which again didn't scale very well. So these are sort of the main problems that we faced, and the kind of the main categorization. So what the most important thing for our users really was kind of three big things, right? We wanted the ability for them to search and browse important data assets, and this meant reports and data sets to start. And data sets meaning any sort of data set, whether it was a Kafka topic, like a streaming topic, whether it was an actual model data set or a raw data set, and of course, like reports and dashboards. And then the other thing they wanted to understand was the lineage, right? That governance, the provenance between all of the data assets that live within that path on that data lifecycle. And finally, they wanted the ability to kind of search or browse through that, right? Like the idea of search, again, wasn't this very specific thing that you would develop in your head. It's not like you already know what you're going to ask. You start with a really high level concept and you have to iterate through it. So we built a tool called Artifact. I'll talk a little bit about kind of buy versus build in a bit, but I wanted to quickly take you through some of the principles that we thought about when building this. So basically, we understood that the data assets themselves and that the metadata that inform them are basically the context that inform everything about the discovery process. So that information then is iterated upon in order to actually arrive at the final kind of understanding of what you're looking for. So as an example, if I'm starting from scratch, I may look for something like rating. Rating might give me a set of results. And then from there, I might refine my search query to find something more specific, and so on until I get to an answer. Very similar to what Mark showed, same sort of points and same ideas. I won't get into too much details of what the solution looks like. Generally, it's a search and browse tool. You're able to search for data sets, fields, reports. You're able to do this by different source, right? So whether it's coming from our modeling systems, whether it's coming from our raw systems, whether it's coming from our dashboarding or reporting solutions. And you're also able to search by owner. So this is different teams that own these data assets. Again, organized by number of queries, kind of what Mark talked about popularity, right? We have the same sort of idea. It's like queries and usage that are registered against those data assets. Clicking into these data assets takes you to a details page. Again, detailed documentation, including schema, playbook, how to leverage it, who the top users are. You're able to contact them from there. You're able to see the lineage. So all the downstream and the upstream dependencies that exist within that data asset. And then you have some action items from there. You can go out to see actual report itself, or you're able to click through and see what those dependencies look like. From the backend side of things, we had three big development principles that we worked with. First and foremost, we understood that there are no perfect tools. We wanted to solve the problem and solve for the obstacles that have the quickest way to the highest impact. And I know it sounds a little bit like a cliche, but we wanted to make sure that speed to market and shipping that incremental value was front and center for us, because the problem was so fiercely felt by our users. The architecture design had to be generic enough and flexible enough for us to be able to extend this in the future. During our research, we talked about the problems users are facing, and then we tried to go a level deeper to understand, okay, so let's say we solve the big problems of today, which are, your typical kind of hard curation, governance, accessibility problems. What's next on the horizon? And those kind of allowed us to understand, okay, we need to be super extensible, super flexible, because there are going to be issues that we want to address in the future. And lastly, of course, those quick iterations I was talking about, they lead to smaller failures, and failures in our minds were good. We wanted to fail, but we wanted to fail quickly so we can have some clear and focused lessons. The backend, again, pretty similar to what Mark described. We have a bunch of different data systems that we ingest. So we pull data from them. Same reason that he mentioned, we wanted to be in control of these, because a lot of these teams, like you mentioned, are strapped for resources, and we just are not on their roadmap when we started this. Though lately we've started to have those conversations about push versus pull with them. You have the metadata extractor, which is basically our data model. That data model itself was probably the most complex part of all of this, in addition to the lineage graph. But that was the part that we spent the most time on, just making sure that we're able to build something generic enough to help us in the future to be super responsive to our users' needs, but also be able to address the problems of today. And then, of course, we fit all that into Elasticsearch and surface it through GraphQL to the web application. Really high level. I'm not going to get into too much detail on the solution itself in terms of the engineering side of things, but this is kind of similar to what I've seen out there from other applications. Did it work? Prior to actually building Artifact, we'd sent out a survey to all of our users, and what we got was a few questions, but I pulled this one specifically because I think it really highlights just how much of a problem this was for us. Before Artifact, 80% of our users agreed or strongly agreed that the current discovery process hindered their ability to deliver results, like to actually deliver positive outcomes from their jobs. That's extremely demoralizing and something that informed us to be very quick about and speed to market being super important, right? So after launching Artifact, we gave it some time, we ran another survey, and we found that number to drop to 41%. So a huge improvement, but again, incremental nature of this, right? We knew that we're not going to solve all the problems, so we wanted to make sure we got the big ones out of the way. We still have a long way to go, but it was nice to see that positive impact. In terms of usage, we see some really interesting numbers about, I think 40% or so data employees use this on a weekly basis. It's mostly prevalent with our data folks, although we're starting to see non-data folks leveraging it highly as well. So lots of really good usage and good feedback. Just in general, people are super happy with this. I want to talk a little bit about some of the risks that we had to mitigate along the way. The biggest one for us was content, right? Without the documentation, this tool doesn't really work. So how do we mitigate for this? We partnered with all of our data science teams and worked with them to figure out a way to put together some templates that are documentation templates that all data scientists could align to, and then work with them to start documenting data sets that were most important, like the big ones right off the bat. And then we worked our way down that priority list. But the important thing for us is that our data sets, when they're produced, that's when you have the opportunity to create your documentation. So what we want to do is we want to enforce some level of documentation at source, so that when a data set or a data asset is created, that documentation is created along with it. So we're able to just pull that in. The curse of being downstream of literally every data system in the organization meant that we had to work with every team from whom we pulled information from to be constantly informed about the efforts that they were doing. So any sort of changes they were making to their products and their tooling, we had to be kept informed. And that involved both us sitting with them and following their projects and making sure that collaboration is constant. And them also realizing, that we are a pretty big application downstream and reaching out to us when they were making changes. So there was a little bit of a give and go there, but I think the initial kind of conversations were definitely started by us to make sure that we were not affected by any downstream or upstream changes. And finally, user experience and design. I know this might be something that's kind of a given, but I just want to highlight it. No matter how good your backend system is, no matter how much data you collect or metadata you have, if you're not presenting this in a way that's easy to consume and understand, you don't have a good tool. So we ran quite a bit of UI research in terms of like putting together mocks in front of our users, working with them to understand what works, what doesn't, where are they hung up, so that we can get the optimal experience for them when they are discovering data sets. Because again, like the goal is to scale our data scientists and our data folks. And in order to do that, we also have to make sure that this process is as frictionless as possible. So I'm going to touch a little bit on the why not buy solution. So Mark had a really awesome trade-off kind of requirements section in his presentation. It's very similar to what we talked about as well. I can summarize that into kind of like four main areas for us. The biggest was cost of integration. And I don't just mean that in terms of effort, I mean that more so in terms of time, right? So for us, speed to market, super important. And what we saw was integrating with a third-party software at the time that we were evaluating this, there wasn't anything for us to be able to deliver on one of the biggest issues, which was lineage. And I think that was the one that kind of right off the bat started us down the path of, okay, I think we might have to build this ourselves. And that in together with this technical debt accumulation, which I think is a very engineering focused problem, but from a product perspective, if I'm unable to deliver value to my users in the future because we've accumulated a lot of tech debt, then that becomes a product problem for myself. So what we thought about in the future was, okay, like if we are buying or partnering or going with an open source solution, how easy or hard is it going to be to integrate things that we want to integrate in the future or solve some of the future problems for our users? And that was increasingly harder and harder. So we chose that the UI side of things was pretty easy for us to build. We knew the biggest meats and potatoes of what we're going to work on was that data model. So that cost of integration would have been worked on anyway. So we decided to go ahead and build it. The last couple of things I think are not talked about enough. Organizational culture is a big aspect when you're building things. Shopify is a culture of builders. It's an engineering organization. We're very good at building software. So we wanted to make sure that we are able to leverage these resources in the most efficient way, which allowed us to develop a tool that was specifically suited to our users. One of the other questions I get is kind of like, what do you think is Artifact's biggest flaw? It is precisely that it's a web application. Yes, it is a single source of truth for our metadata. However, it means that users have to go to Artifact to use it when they're doing other things. So for example, let's say I'm a data scientist and I am building a data model and I need information on the inputs that I'm consuming from. I have to Alt tab or Command tab into Artifact to see that, right? So we want to be able to provide this as a service, and I'll talk a little bit about what's coming up for Horizon. But the most important thing with metadata is providing metadata to the right person at the right time when they actually need it, without disrupting their workflow too much. So what's next? I just talked about it. Discovery as a service. Like that's something that we are very keen on. We've started exploration on how can we ship metadata as a service and allow teams to API in and grab it when they need it. So our modeling teams can API metadata into their workflows. Our reports and dashboarding can do the same. So that is something that is very important to us. The second one is change management. Change management typically, we started off with this idea of lineage and being able to traverse lineage and notify users when you're making a change. We want to automate that even further. We want to make sure that we're able to end-to-end allow users to not just understand who their consumers are, but be able to actually speak to them when they're making those changes and flag anything that's slated for deprecation so that teams have the opportunity to start moving off of those data assets. And lastly, completing data lifecycle coverage, right? So this involves just adding additional data assets that we've purposely omitted from the initial solutions because, again, speed to market was important. And these are ones that are not leveraged as much, but are seeing increased usage. So this is stuff like our product analytics tooling and some of the other first-party production data sets. So thank you. It's a very high level overview. Thanks for having me here. Please ask any questions. I'm happy to answer them. You can reach out to me on LinkedIn at Ranko if you have any other questions. And yeah, happy to answer.
Thank you, Ranko. Yeah, great talk. So questions, please post it to the Q&As instead of to the chat. I noticed there are a few questions in the chat, but if you have questions, please post there. So let me just read through some of the questions. Okay, so I got one question from there. Does the artifact search results factor in the user's search history and identity? And that is my Google search results differ from yours.
Yeah, not yet. So not yet. So the whole idea of user for now is just tied down to the team. But we are going to start working a little bit more about identity and trying to understand the relationships between teams, the search history, and leveraging their interconnections within the metadata graphs.
Okay, so the next question actually coming from Mark. So it's how do you enforce that the data sets is not created or ingested without appropriate documentation being there?
Yeah, so we have a bunch of CI checks. So there's a couple of things that happen. In our latest edition of our data modeling software that we're building, users are not, like your CI check will fail if you don't have documentation. Now, we don't check the quality. Obviously, like, if you're writing and if you just write a bunch of Latin and publish, like, sure, like that will go through. So we leverage this kind of like carrot and the stick, right? Like we have multiple kind of documentation drives that are spearheaded by our champions, our data science champions, who will leverage their kind of network and their influence to create documentation drives where a bunch of data scientists will get together, go through and take a look at the data sets that are least documented, most leveraged, and actually document those. And then the other thing is like coverage reports to data science leadership, where they're able to see kind of where their weak spots are and kind of enforce a more stricter approach to documentation.
I see. So there's one more question. So this is from the chat as well. So do we expect a cloud-based managed data discovery and a metadata platform for your company? Any commercial features?
No, so not yet. So that's not, we're definitely not there yet. I think we are constantly changing in terms of figuring out what the best approach to this is going to be for us. Again, we're downstream of a lot of our systems, and I think as we kind of grow our data platform, we're going to have to standardize and figure out what we want to do with discovery going forward. I think once that's a little bit more settled, and once we have a solution that I think solves more of our problems, I think that would make sense to go that route.
Okay. So the next question from the one member is any plan to open source this artifact?
Yeah, we've talked about it. We've had a few conversations. I think same sort of answer as before. I think before we all open source it, we'd like to get a lot more features in there and get a little bit more. Like we want to be able to support the API side of things and being able to actually push metadata and develop that metadata service as part of Artifact. Because right now it is mostly a standalone web app. So I think before we get there, it wouldn't necessarily make as much sense to open source, but I think eventually we might consider it.
Okay. So the other questions saying, do you handle escalations? Do you handle evolution of a data set ownership automatically within Artifact, or does this have to be done manually?
Yeah, so it's handled based on the system that publishes the data asset, right? So if it's a data set, a modeling data set, then whenever the ownership changes within that system, it's reflected within Artifact. We are actually building in a detailed logging of change management so that people can see not just like ownership changes, but update changes, and as well as like kind of the severity of downstream impacts from those changes.
I'm curious, and I follow up on this question. I'm curious, so does this also put a lot of strains on the product team or development team who generate the data? Like, for example, if I'm talking to my mobile teams or the e-commerce teams and to say, okay, please not only sending me the data, but sending all these documentations with all these taggings. And that's, all of a sudden there's a ton of work for them. And, frankly, not every teams are very keen to send analytics data or event data. So they probably only focus to get their product work. Analytics depends on company's culture. And the analytics side, sometimes it's a secondary citizen. Or so adding these additional things are just adding more strains to the product teams. So how do you solve that?
Yeah, so culturally, I think that's a good point. For us, because data scientists are embedded in product teams, it is kind of practiced into the culture of the product team. So when you are, let's say you're developing a new product or a new feature, that analytics is part of that process, right? Because our data scientists are there. So they're the ones who steward that, and they're the ones who own the creation of these things and documentation of these things. So it is extra work for sure. But I think our data scientists will be the first to tell you, because they experience the value of having other data sets documented, they understand how valuable it is for them to do the same for others.
So there's one more question. Is there any data quality tools that you use internally in Shopify, and if whether that can be integrated with Artifact?
Yeah, so that's one of the things that we're going to be considering in the next couple of years. Right now, we have some data quality processes that we've built ourselves, but we're still very much trying to figure out what that looks like in the future and how that integrates with Artifact. So I think what we've done from an Artifact perspective is we've held off on that purposely until we standardize that org-wide, and then we'll start to push through. Like, I think that for our users, because again of the decentralized nature of our data organization, that's not as much of a problem as it is for example, as it would be for something that's a little more centralized.
So how big is your team? So how big is this overall data team? How many people working on this product?
Yeah, so we have over 250 data scientists. You mean how big is the team that built the artifact?
Well, just the data organization. How big is the data organization? How big is the data artifact team?
Yeah, so the data science, I think we have over 250 data scientists last time I checked, but there could be more now. We're growing pretty quickly. We're hiring quite a bit at the moment. And the team that built it was, I think we had 4 engineers, a team lead and designer, and a product manager. That was myself.
Okay, cool. So I don't see more questions from the community. Mark and Anya, so if you guys want to have any questions.
I do have a quick question. Do you have the ability to give permission to an individual user to say, oh, this user has permission to view, read, or update this particular piece of data?
Yeah, so again, it's a good question, because this is like organizational culture plays a big role in how these tools are built, because they sit so downstream of a lot of the kind of the processes that exist within data, but also outside of data. So one of the cultural pillars for Shopify is we default to open internally, right? So everybody has access to every data set. And then those who are by nature like human resources systems, they sit on a separate stack altogether. So yeah, we haven't had that become a problem just yet, though we are keeping a keen eye on it, because definitely we're going to want to implement some level of governance there, but yeah, not as big of a problem for us.
Makes sense.
So what about the financial data? Do you collecting that? Usually the financial data is separated out from the rest of other data.
Yeah, some of the financial data is separated and only sits with those who need access to it. Generally, specifically financial analysts. Yeah.
Cool. Mark, you work on the same topic, and say have any question for Renko?
I already asked mine. It's a great talk. Thank you for sharing, Renko.
Thanks, Mark.
All right, thank you so much, Renko. And like again, we're thanking for both speakers, Mark and Renko. Talking from the two companies, coming from two different aspects, but working on the same area of the problems. So, and we also like to thank AI Camp, Bill Liu from AI Camp, helping providing the Zoom services for us and helping to hosting this. And so without AM camp, and we cannot have this online. So, we can't thanks enough. So most importantly, thank you all the members who take their lunchtime or whatever the times, morning time, evening times for across the world to attend this this session. So, thank you, and we'll see you next time. Okay, bye-bye.
Thank you, Chester. Bye.